Okay, so the last part that we're going to talk about today, the last section of this chapter, is going to be on equations of a circle. So just like lines and quadratic functions, just like all of those have equations, a circle also has an equation. So think back to when you first started doing algebra and you talked about linear equations, which were usually in the form y equals mx plus b. Sometimes you put them in point-slope form, but most of the time in slope-intercept form, y equals mx plus b. Quadratic functions typically take the form y equals x squared plus something x plus or minus some number. So quadratics are a quadratic trinomial. An equation of a circle is, it looks like this. This is the equation of a circle, where hk is the coordinate of the center of the circle, and r is the radius. So x and y, just like in y equals mx plus b, you leave the x and y. That should stay in your equation. So the stuff that you're looking to plug in is the h, the k, and the r. So typically, from the equation of a circle, to graph it, you would need the center and you would need the radius. So we're going to talk about sort of how to write those equations and where they come from. So to begin, like where it comes from, the equation of a circle comes from the fact that every circle, the radius, what is a radius? Half of the diameter, okay, but how else could you describe it? A segment from the center to the other, not the other center, there's only one center, the outside, so the edge of the circle, right? Does it always have to be in the same spot? No. There's how many radii in a circle? Infinite, right? It goes all the way around. There's an infinite number of radii, but they're all what? The same distance. Every one of them is equal. So the equation for a circle comes from that. This, does anyone recognize this formula? Yes. Distance formula. This is the distance formula where instead of x1 and x2, for one of the x1s and y1s, we plug in the center. And then the distance is always going to be the radius because it's from the edge of the circle all the way to the center of the circle. So that's where h and k come from. And then the distance becomes r because that distance would just be the radius of the circle. So that's where the formula comes from. And then to simplify it a little bit more, how did we go from, if we call this the second step, how did we go from line 2 to line 3? What happened from line 2 that changed to line 3? You square both sides so that what happens? You don't have to deal with the square root. So essentially the equation of a circle is the distance formula, but they got rid of the square root and you plug in, what is h and k again?
Height?
It's not height.
It's the center?
It's just the center. It's just the coordinates of the center. So they don't want to call it x and y because you still want x and y in the equation. So they just use different letters. So h and k is just the coordinates of the center of the circle, where h is the x coordinate and k is the y coordinate. So why did they pick those letters? I don't know. But those are the equation, or those are the letters for the center of a circle. So hk would be the center of a circle. All right, and r is always the radius. So when you have the equation of a circle, the information that you're going to need is the radius and the center. So when you plug stuff in, the way you want it to look is, this would be an example of an equation of a circle. So it would be like 5 squared equals x minus 2 squared plus y minus 4 squared. So your equation should look something like this. Okay, just like when you did a linear equation before, you would want it to look like, you'd want it to be something like this so that you could graph the line. So this would be the slope and the y-intercept, slope and y-intercept, so that's how you would graph it. So in an equation of a circle, you want this stuff filled in because then what's your radius? What's the radius of this equation, of this circle? 5, good, so the radius is 5. Okay, and then what's the center? 2, 4. Okay, so that's always the information that you're looking for. If you have that information, you're just going to plug that in. So say you have radius So then to plug that in, I would just plug it into that formula. So r squared, and I write that as just 4 squared, equals, what would x be here?
Positive 3.
Yes, y positive 3.
Because negative 3.
Good. It's a x minus negative 3, which becomes a positive 3. Okay, plus, and then it would be y minus 2 squared. Right? So that's what you want your equation to look like. And that way you can get all the information you need from it so that you can graph it. Now, obviously, you guys can probably predict it's not always going to look like that. Sometimes you have to do some algebra to make it look like that. Okay, so how would we write circle A with a center at 4, negative 2, and a radius of 3?
3 squared equals parentheses x minus negative 4 squared plus y plus 2.
Good.
Squared.
Good. Okay, so again, we're just plugging in what we know. So this is our r, and then this is our h and our k. And remember that it's minus, so it should actually be kind of like the opposite of what it is in the coordinate. So it's minus 4, and then plus 2, because a negative negative would become a positive. If you write y minus negative 2, that's also correct. It's just shorter to write y plus 2. So either of those is fine. It's just shorter to write it the other way. Okay? What would you do here for b? What do you have there? You have the center and...
Did you put it in a little thing?
Yeah, you put it in the formula, right, to figure out the what? The radius. So we're still going to do r squared, but I don't know what it is. So what's my first x? Okay, so it'd be negative 2,
Plus
6 squared, plus 6 squared. So again, we're plugging that in so that we can find the radius, because ultimately we need it to look like this. Okay, so what's negative 2 plus 6? 4. 4 squared is 16. And what's 6 minus 3? 3 squared is 16 plus 9 is 25. So r squared equals 25. So then r equals 5. Good. So then when I write my equation, I write 5 squared equals x minus, and which one do I use? This one or this one? B. Why B? I have to use the center. Exactly. So I have to use the center, so I'm going to do x minus negative 6, which is actually plus 6 squared, plus y minus 3 squared. So when you're doing these, again, the goal is to have which variables left? X and y. Okay, x and y should be left in your answer. So if you don't have the r, you need to find it. Now, you could also write this as 25. If you want to simplify that part of it, that's fine. So you could say like 25 equals x plus 6 plus y minus 3. Okay, go do these 5. Okay, so let's talk about graphing them then. So then, given an equation of a circle, how would you graph it? To graph a circle, then you just need those two pieces of information, right? You need the center and the radius, because if you have the center and the radius, let's say, for instance, here's your coordinate plane, and I know that the center for this one is 7, 0, and the radius is 3. So then how would I start that? To graph it, what would I do? Go to 7, 0. So 1, 2, 3, 4, 5, 6, 7. Okay, so here's my center. And then the radius is 3. So what would I do from there? Go out 3. So 1, 2, 3. And then what? Go up 3. 1, 2, 3. Down 3. And left. And then Ivan what? Okay, 1, 2, 3. And then just connect them. Obviously, is this perfect? I know it looks kind of like an egg. But it's not going to be perfect, particularly when you draw your own coordinate plane, because you're not measuring it exactly. But that's how you do it. So what two pieces do you need? Center and the radius. So again, think back to when you did linear equations, y equals mx plus b. You needed the slope and the y-intercept. Here, it's even simpler than that because there is no slope. You just need the radius and the center. So how would you get that from an equation like this? So this does not look like the equation of a circle that we've looked at, right? So how can you make this look like the equation of a circle? Well, first of all, look at this. This part must be the what?
The radius.
The radius squared. So it would be, so the radius here would have to be 5. Good. So I'm going to go 5 up, left, right, and down. Okay. But I need to find the center. What would the center be? Do not say anything. What would the center be if you're just looking at this equation and it looks like I don't have one? So if it's like I don't have it, then what numbers would there be, Mariah? 0, 0. Exactly. So if there is nothing here, you can assume that it would be like this. Because do you even need to write the -0 there? No? So if it looks like this, you assume that the center is the origin or 0, 0. Okay? So whenever an equation looks like that, it starts at 0, 0. And then we just go over how many?
5.
Good. If your radius is 5, what's your diameter?
10.
10. Okay, so this one's actually going to cover the entire coordinate plane that we have here. All right, that one looks more like a circle.
Yeah.
All right, less like a football. Okay. I'm going to sit at my desk and just laugh when you try to graph the next one. Okay? All right, so I understand it's hard to draw circles. I get that. So if you're perfect at it, good. I'm not. I recognize my weaknesses and I move right on. Okay, so if it looks vaguely circle-ish, then that's good. As long as all your radii are the same, then that's what needs to happen, okay? And technically now, if I went from here to here, this should also be what? 5, okay? So it's a radius, yeah, so it would also be 5. Now, did I draw it perfectly? No. So if I did that, it probably wouldn't be 5, but that's what it would be if it were a perfect circle. Okay, what if the equation were this? All right, I need to figure out my center and my radius. So start with the radius. What's my radius? 3. Why? Yeah, because 3 squared is 9. Okay, what's my center?
3 -4.
Why is the 3 negative but the 4 is, or 3 positive but the 4 is negative? It's opposite. Good. So where would I start? No, the radius is r squared. So if this is 9, then the radius would have to be 3 because the square root of 9 is, yeah. So center is 3, -4, radius is 3. So where do I start? You start at the center. So I go over 3, down 4. So that would be right here. And then from there, what would I do? Because it's not going to fit. So how many of them could I put on there? I can put 2 on. So I've got 1 and 2. And then I'm just going to estimate about where it would be. It would be about here. Okay, so again, they're not perfect, but that's where you started. I'm sorry. Are you going to be okay? All right. I cannot. All right. Well, when you all have a second, Miguel, when you're done glamming, can you guys go graph these two at your boards?